Get ready to code.
Get ready to do innovation.
Get ready to understand way of professional coding.
Tutorials will be started from basic to advanced level of programming.
So what are waiting for? Just hit the subscribe button.
Like, subscribe, and share. This is my workspace. My name is Gracie. So let's start with tutorial of Internet. Before starting with mechanism of Internet, let's learn history of Internet. In 1965, two computers at MIT Lincoln Lab communicate with one another using packet switching technology. In 1968, Beranek and Newman, Incorporated, BBN, unveils the final version of the Interface Message Processor (IMP) specifications. BBN wins ARPANET contract. In 1969, on October 29, UCLA's Network Measurement Center, Stanford Research Institute, SRI, University of California Santa Barbara and University of Utah install nodes. The first message is low, which was an attempt by student Charles Klein to log in to the SRI computer from the university. However, the message was unable to be completed because the SRI system crashed. In 1972, BBN's Ray Tomlinson introduces network email. The Internetworking Working Group (IN) forms to address need for establishing standard protocols. In 1973, global networking becomes a reality as the University College of London, England, and Royal Radar Establishment, Norway, connect to ARPANET. The term Internet is born. In 1974, the first Internet Service Provider (ISP) is born with the introduction of a commercial version of ARPANET, known as Telenet. In 1974, Vinton Cerf and Bob Kahn, the duo said by many to be the fathers of the Internet, publish a protocol for packet network interconnection, which details the design of TCP. In 1976, Queen Elizabeth II hits the send button on her first email. In 1979, Usenet forms to host news and discussion groups. In 1981, the National Science Foundation, NSF, provided a grant to establish the Computer Science Network, XNet, to provide networking services to university computer scientists. In 1981, the National Science Foundation, NSF, provided a grant to establish the Computer Science Network, XNet, to provide networking services to university computer scientists. In 1982, Transmission Control Protocol, TCP, and Internet Protocol, IP, as the protocol suite, commonly known as TCP/IP, emerge as the protocol for ARPANET. This results in the fledgling definition of the Internet as Connected TCP/IP Interface. TCP/IP remains the standard protocol for the Internet. In 1983, the Domain Name System, DNS, establishes the familiar edu, gov, com, mil, org, net, and in system for naming websites. This is easier to remember than the previous designation for websites, such as 123.456.789.10. In 1984, William Gibson, author of Neuromancer, is the first to use the term cyberspace. In 1985, Symbolics.com, the website for Symbolics Computer Corporation in Massachusetts, becomes the first registered domain. I know, history is boring, but what can we do? We should know how Internet had evolved. In 1986, the National Science Foundation's NSFNET goes online to connected supercomputer centers at 56,000 bits per second, the speed of a typical dial-up computer modem. Over time, the network speeds up, and regional research and education networks, supported in part by NSF, are connected to the NSFNET backbone, effectively expanding the Internet throughout the United States. The NSFNET was essentially a network of networks that connected academic users along with the ARPANET. In 1987, the number of hosts on the Internet exceeds 20,000. Cisco ships its first router. In 1989, World.STD.com becomes the first commercial provider of dial-up access to the Internet. In 1990, Tim Berners-Lee, a scientist at CERN, the European Organization for Nuclear Research, develops hypertext markup language, HTML. This technology continues to have a large impact on how we navigate and view the Internet today. Hey student, today I will teach you about working of internet.
That's interesting topic, ma'am.
Can anybody tell me how website is located?
Yes, ma'am. Computer are connected to internet would have some need to track down to get its data to the computer who accessing it.
Yes, Samir, that's right, but it not it is address of computer. Let us see how. Internet is a global network of computers. Each computer connected to the internet must have a unique address. Internet addresses are in the form NNN.NNN.NNN.NNN, where NNN must be a number from 0-255. This address is known as an IP address. IP stands for Internet Protocol. More on this later. The picture below illustrates two computers connected to the internet. Your computer with IP address 1.2.3.4 and another computer with IP address 5.6.7.8. The internet is represented as an abstract object in between. As this paper progresses, the internet portion of image shown in will be explained and redrawn several times as the details of the internet are exposed. If you connect to the internet through an internet service provider (ISP), you are usually assigned a temporary IP address for the duration of your dial-in session. If you connect to the internet from a local area network (LAN), your computer might have a permanent IP address, or it might obtain a temporary one from a DHCP (Dynamic Host Configuration Protocol) server. In any case, if you're connected to the internet, your computer has a unique IP address. In next slide we will learn about protocol stacks and packets. Backbencher are not taking interest in lectures.
Ma'am, I think they come here to sleep. It's not your fault, but they don't want to study.
Let's leave them and move ahead to next topic, that is, how protocol stacks and packets works. Imagine we two IP address, let's name it 1.2.3.4, and other is 5.6.7.8. Computer is connected to the internet and has a unique address. How does it talk to other computers connected to the internet? An example should serve here. Let's say your IP address is 1.2.3.4 and you want to send a message to the computer 5.6.7.8. The message you want to send is "Hello computer 5.6.7.8. Obviously, the message must be transmitted over whatever kind of wire connects your computer to the internet. Let's say you've dialed into your ISP from home and the message must be transmitted over the phone line. Therefore, the message must be translated from alphabetic text into electronic signals, transmitted over the internet, then translated back into alphabetic text. So can anyone tell how this could be accomplished?
Yes, ma'am, I can tell.
Tell Samir.
Through the use of a protocol stack. Every computer needs one to communicate on the internet, and it is usually built into the computer's operating system, that is Windows, Unix, etc. The protocol stack used on the internet is referred to as the TCP/IP protocol stack because of the two major communication protocols used.
Right, Samir, your answer is absolutely correct. Let's see in PPT layers of TCP/IP or it look like. First, the message would start at the top of the protocol stack on your computer and work its way downward. If the message to be sent is long, each stack layer that the message passes through may break the message up into smaller chunks of data. This is because data sent over the internet and most computer networks are sent in manageable chunks. On the internet, these chunks of data are known as packets. The packets would go through the application layer and continue to the TCP layer. Each packet is assigned a port number. Ports will be explained later, but suffice to say that many programs may be using the TCP/IP stack and sending messages. We need to know which program on the destination computer needs to receive the message, because it will be listening on a specific port. After going through the TCP layer, the packets proceed to the IP layer. This is where each packet receives its destination address, 5.6.7.8. Now that our message packets have a port number and an IP address, they are ready to be sent over the internet. The hardware layer takes care of turning our packets containing the alphabetic text of our message into electronic signals and transmitting them over the phone line. On the other end of the phone line, your ISP has a direct connection to the internet. The ISP's router examines the destination address in each packet and determines where to send it. Often, the packet's next stop is another router. More on routers and internet infrastructure later. Eventually, the packets reach computer 5.6.7.8. Here, the packets start at the bottom of the destination computer's TCP/IP stack and work upwards from hardware to application layer. As the packets go upwards through the stack, all routing data that the sending computer stack added, such as IP address and port number, is stripped from the packets. When the data reaches the top of the stack, the packets have been reassembled into their original form. Hello Computer 5.6.7.8.
Thanks for watching, and don't forget to subscribe the channel and hit the bell icon